So in this video, we're going to talk about free fall. Free fall is a type of motion where that happens when objects are acting under gravity. So the acceleration for a free falling object, the acceleration is just g. G is a name for the acceleration of gravity. And so this is a type of motion that can be studied using the equations for constant acceleration. Let's remind ourselves of those equations. We have the final velocity is equal to the initial velocity plus the acceleration times t. Then we have the final velocity square is equal to the initial velocity square plus 2 times the acceleration times the displacement. And then finally, you would have the final position is equal to the initial position plus the velocity times delta t plus 1/2 acceleration times delta t squared. So those are the three equations for constant acceleration. So all we need to do to convert this to study free fall is to change acceleration for gravity. So the equations that we are going to use now, that the way these equations are going to change is this way. So the final velocity is going to be equal to the initial velocity and then gravity, right? So here is the acceleration of gravity. Typically, we are going to choose that to be negative, and then we get this equation here. The final velocity squared is equal to the initial velocity squared minus 2 times g, which is now the acceleration, times delta y. And delta y, because we typically are going to be concerned with vertical motion. And here we are going to have that the final position is equal to the initial position plus the initial velocity times delta t minus 1/2 g delta t squared. So those are the equations. This is the way these equations are going to change. So let's see this in a little more detail. So an object that is falling, here we have a motion diagram for an object that is falling. So you can see the points at which that object is at different times. So, and this is the acceleration, which is minus g, if you choose a coordinate system that points up, right? So the value of the acceleration is 9.8 meters per second squared. Every second, the object is going 9.8 meters per second faster. So if you plot the velocity versus time graph, which is this graph here, velocity versus time, that would be a straight line. And the slope of this straight line, if you do the rise over run, the slope of this is just 9.8. It's this number here. All right. So some key points about free falling motion. Free acceleration always points down. So that's why typically we say the acceleration of free falling motion is minus g. This minus reminds you that it's pointing down. So free fall happens when the only force acting is gravity. So that means the only acceleration happening is gravity. And the value for the acceleration, the value that we're going to use for most problems, is 9.8 meters per second squared. So g is a constant, is a name that we give to the acceleration of gravity. This number is always positive, and by definition is 9.80 meters per second squared. However, the acceleration is a vector and it has a direction. So the acceleration is minus g. So you have the minus in front of g, which is a positive number. So we use the kinematics equations for constant acceleration. The value is 9.8. And sometimes we will talk about units of acceleration in units of g. So if you sometimes they say that a rocket has an acceleration of 2.2 times g, right? So when you say that, it means that the acceleration would be 19.6 because it's 2 times that number. So let's look at an example here. You drop a rock, right? So you drop a rock from rest, so from a cliff, and it falls 100 meters before hitting the ground. What is the time that it takes to hit the ground? That is a typical problem, and also we would like to know what is the final velocity. So let's look at our steps to solve the problem. We strategize. So this is a free falling problem, right? So g is constant, so we know that. And we are going to use the equations for constant accelerations, with the acceleration being minus g. So let's prepare the problem. So that means drawing a picture. It could be good to draw a free motion diagram, which is here. So here we have the visual diagram. We have the rock. And so this is the initial condition, the initial state, and the final state here. So we have the acceleration here, and these are the things that we would like to know: initial position, initial velocity, initial time, final position, final velocity, and final time. What do we know? Well, we know the initial position is 100 meters, so we know this guy. The final position is 0, right? So we know this guy. We can always set our 0 here, and this is 100, right? So that's where we started. So start from rest. You're just dropping. You're not throwing the rock. So that means this is 0. So we know this guy. And the acceleration is minus 9.8. So we know this guy. So we can always set the time equal to 0. So Ti is equal to 0. So we know this guy. And these are the things that we want to know. We want to know this guy here and this guy here. So let's see how we solve this problem. So we start by using first the one of our equations for constant acceleration. Final position equals to initial position plus initial velocity times the interval time. So that delta t is equal to t final minus t initial. And this t final is what you want to know. So that's what goes in here. And then you have plus 1/2 acceleration times delta t squared. In here, we're going to have minus g, right? Because that is our acceleration. So this equation becomes initial. So this we know. And then the initial velocity is 0, so this whole term goes away, right? So you're only going to be left with the initial position and minus 1/2 g delta t squared, right? And there is an equal sign here that was missing. And if delta t is this guy here, this becomes that the final position is equal to the initial position minus 1/2 g t final squared. So this is one thing we want to know, right? So this tf, and we know this, we know this, and we know this. So this is an equation that we can solve. We can solve for tf, and that's done here. And if you solve for this, you put your numbers, you get that this is 4.5 seconds, 4.52 seconds. So that is the time it takes to hit the ground. So the second part of the question is finding the final velocity, right? So for that, we use this equation. We are going to use this equation here. Final velocity is equal to initial velocity plus a times delta t, and a is going to be minus g, and delta t is going to be tf, right? So this becomes final velocity here is equal to initial velocity minus g times delta t, which is tf. We know tf now from here is 4.52. We know the acceleration, and this guy is 0 here, so you get that the speed is minus 44.3 meters per second.